Okay, so here's our problem. We want to find the volume of the solid obtained by revolving the function sine 7x for x between 0 and pi about the x-axis, okay? So I think it's useful to take a look at the curve, okay? So there it is. And we're gonna rotate that around the x-axis. So that's sine 7x from 0 to pi. We're gonna rotate it. Okay, so you imagine this carving out of three-dimensional space a volume, okay? And by symmetry now, we have 7 equal pieces, okay? So you can imagine 7 sort of oval-shaped discs, right? So there are the 7 pieces. And so we can just find the volume of one of those and multiply by 7. Okay. Now we're going to need the radius. We're going to look at each oval and we're going to slice that now into discs, very thin discs, okay? And the radius of those is going to be the value of the function at x, okay? So the radius is equal to sine 7x. Okay. So now the volume of each, so remember we're taking the oval, we're slicing it into to very skinny discs, and they have a width of dx, okay? It's pi r squared times the width, which is dx, okay? And so basically you should be thinking about integration here now, right? Integration is going to take all these tiny discs and sum them up together to give you the volume. Okay, so let's look at the integration now. Okay, so the total volume is going to be 7 because there's 7 pieces. I pulled the pi outside, and we need to integrate sine squared 7x. Okay, now, to make this easier, there's an identity that comes from the cosine double angle. Okay, now I'm not getting deep into integration here. I'm just basically providing the answer, but you should do this on your own, verify that I've got it right, and the key here is to rewrite the sine squared 7x in terms of cosine 2x. Okay, so we double the 7x to 14x basically. Okay, and then we're gonna split that into 2 pieces, okay? And each one of those pieces now is fairly easy to integrate. So first one, oh yeah, okay, so the first one is 1/2 x, and then you integrate the cosine, you get sine x, and the 14 goes in the denominator. And we're going to evaluate these. I should have mentioned in the beginning the limits 0 to pi over 7. That's because we're just looking at the first piece. Okay. All right, and we got to just evaluate this. And one thing to notice here is that at 0, okay, the first piece 1/2 x is 0. Second piece also 0 because sine of 0 is 0. Okay, so now we only have to evaluate now at pi over 7. So next step, I'm going to factor out the 7 pi, and we put in pi over 7, and we get that. And then notice that sine of 2 pi, that's also 0, so that disappears. And we're whittling this down to a pretty simplified form. Huh? Pi squared over 2. Right. Now let's think about the reasonableness of this. Does it make sense? Think of a cylinder. If we had a cylinder that was pi in length laying down on its side and a radius of 1, the volume of that would be pi r squared, so pi r squared, yes. So r squared is 1. So we just have pi times the length, which is pi pi squared. Okay, so the volume of a cylinder would be pi squared. This is half of that. Seems reasonable. Okay. Check my work though, please. I hope I'm right. But the main point of this video is to just illustrate how to visualize these things. All right, I hope that was helpful.